Imagine waking up tomorrow and every single volcano on Earth decides to go off at the same time. Not just the famous ones, all of them. The quiet ones sitting under oceans, the sleeping giants buried under ice, the ones scientists almost forgot existed. Every single one, all at once. Boom! Now, before your brain writes this off as pure movie fantasy, here's the thing. Earth has done something close to this before, and it nearly ended life as we know it. So let's talk about what actually happens when the planet loses its mind all at once. First, you need to understand the scale of what we're dealing with. Right now, at any given moment, about 20 volcanoes are actively erupting somewhere on Earth. That sounds like a lot until you find out there are roughly 1,500 potentially active volcanoes on land alone. And then there's the ocean floor, where an estimated 3 million underwater volcanoes sit quietly under miles of water. So when we say all volcanoes, we're not talking about 20. We're talking about something so large your brain genuinely refuses to visualize it. The first few minutes would actually be quieter than you'd expect. Not silent, but quieter. Most volcanoes don't just explode the second they decide to wake up. Magma has to push through miles of solid rock to reach the surface. So in those opening moments, you'd feel it before you'd see it. The ground across entire continents would start shaking simultaneously. Every seismograph on Earth would flatline because the instruments aren't built to read something that enormous. Scientists in monitoring stations from Alaska to Indonesia would be staring at their screens thinking their equipment broke. It didn't break, the planet just coughed. Then the eruptions begin, and this is where things get genuinely hard to describe. The volcanoes on land start venting first. Places like Yellowstone in the United States, which sits on top of a supervolcanic chamber so massive that if it erupted on its own, it could bury half of North America in ash. Mount Etna in Italy, which has been grumbling for decades, suddenly stops grumbling. Popocatépetl in Mexico, sitting right next to one of the most densely populated regions on Earth, opens up. Then Taal in the Philippines, Merapi in Indonesia, Nyiragongo in the Democratic Republic of Congo, all of them simultaneously doing what they've been threatening to do for years. Within the first hour, the sky starts changing color. Not a beautiful sunset kind of color change. Ash columns from individual supervolcanoes alone can reach 50 kilometers into the atmosphere. Stack hundreds of those erupting together and you have a wall of material going up into the stratosphere faster than any weather system can process it. The ash doesn't just float there looking dramatic either. It's sharp, microscopically sharp. It shreds the engines of any aircraft still in the air. It clogs rivers. It buries crops in hours. And it travels. When Mount Pinatubo erupted in the Philippines in 1991, just one volcano, its ash reached countries across Southeast Asia within days. Now multiply that by 1,500 land volcanoes and you see the math getting deeply uncomfortable. But here's where it gets genuinely catastrophic: the underwater volcanoes. 3 million of them sitting on the ocean floor, most of them along tectonic ridges, all waking up simultaneously. The water absorbs a lot of the initial blast energy, so you won't necessarily see massive explosions on the ocean surface right away. What you will see is the ocean temperature rising in certain regions, and what you'll feel is the tsunamis. Every major underwater eruption triggers massive displacement of water. With millions of them going off at once, coastal regions around the entire Pacific, the Atlantic, and the Indian Ocean would face wave events that make the 2004 Indian Ocean tsunami look like someone threw a rock in a pond. That tsunami, triggered by a single underwater earthquake, killed over 200,000 people. This would be a different category of event entirely. Now let's talk about sulfur dioxide, because this is actually the slow weapon in the whole scenario. Volcanoes release massive quantities of sulfur dioxide gas when they erupt. When that gas hits the upper atmosphere, it reacts with water vapor to form tiny droplets of sulfuric acid. Those droplets form a kind of hazy veil around the planet that reflects sunlight back into space before it can warm the surface. Scientists call this volcanic forcing. Climatologist Alan Robach and his colleagues have studied this effect extensively, and even moderate eruptions show measurable global cooling within months. When Mount Tambora erupted in 1815, again, just one volcano, it caused what historians called the year without a summer in 1816. Crops failed across Europe and North America. Famine followed. Lord Byron wrote a poem about the darkness. Mary Shelley, stuck indoors because the weather outside was apocalyptic, started writing a little book you might know called Frankenstein. Now multiply Tambora's sulfur output by thousands of simultaneous eruptions. The cooling effect wouldn't be a chilly summer. We're talking about a volcanic winter that could drop global surface temperatures by an estimated 10 to 15 degrees Celsius within a year, maybe more. Sunlight would be filtered so aggressively that photosynthesis, the process that lets plants turn sunlight into food, would collapse across massive portions of the globe. No photosynthesis means no plant growth. No plant growth means no food chain. The agricultural system that feeds 8 billion people would start failing within a single growing season. And here's the part that's darkly funny in the most inconvenient way possible. The volcanic winter would cancel out the ash damage. Not because either one is good for you, but because the sulfur cooling kicks in right around the time the initial heat blasts and lava flows are at their worst. So you wouldn't be burned and frozen at the same time. You'd get burned first, then frozen, which is somehow worse because it means the suffering has stages. Carbon dioxide tells a different story, though. In the very long term, volcanic eruptions pump enormous amounts of CO2 into the atmosphere. In a mass eruption event, once the sulfur veil eventually settled, which could take years, the CO2 that accumulated during the eruptions would begin driving temperature in the opposite direction. You'd have a volcanic winter phase followed, potentially centuries later, by a warming phase. Earth itself has gone through these swings before. The Permian mass extinction 252 million years ago, often called the Great Dying, is linked to a series of massive volcanic eruptions in what is now Siberia. A region called the Siberian Traps released so much carbon and sulfur over a period of tens of thousands of years that somewhere between 90 and 96% of all marine species and around 70% of land species went extinct. Paleontologist Paul Wignall at the University of Leeds spent decades studying that event, and he described it as the closest Earth ever came to being completely sterilized of complex life. All of that from volcanic activity that unfolded over thousands of years. We're talking about everything happening at once. So where would the safe places be? Honestly, nowhere is genuinely safe in this scenario, but some locations are worse than others. Being near any volcano is obviously the immediate danger zone. But the ash clouds would make breathing lethal across thousands of kilometers in every direction from major eruption sites. The people in the best relative position in the very short term would ironically be those in underground shelters, submarines, or sealed environments. Which means humanity's best survivors in the opening weeks might be people who happen to be in mine shafts, nuclear bunkers, or international research stations in Antarctica. Antarctica, which sits over a volcanic region of its own, by the way, so even that plan has flaws. Now, the honest question sitting underneath all of this is, could humanity survive? And the answer is probably yes, in some form. Humans survived the Toba catastrophe roughly 74,000 years ago. Toba was a super-volcanic eruption so massive, it reduced the entire human population to somewhere between 3,000 and 10,000 individuals. Genetic evidence suggests there was a dramatic population bottleneck around that time. Humanity came out of that event barely a species. We survived on resilience, migration, and probably a level of desperation that's hard to imagine sitting in a climate-controlled room. The world that came after a simultaneous all-volcano scenario would be unrecognizable. Not just physically. The geopolitical map would mean nothing. Borders drawn across ash fields are just lines on paper. Whoever had sealed food storage, water filtration, and enough organizational intelligence to coordinate survival would define what civilization looked like going forward. The archaeological record suggests that major volcanic events have repeatedly shaped human migration patterns. Groups moved, populations shifted toward more stable climates, knowledge was lost and rebuilt. It's happened before in slow motion. We just never had to process it happening all at once. So the next time you see a news headline about a small volcanic eruption somewhere, maybe give it a second look. Not out of fear, but out of a quiet recognition that the Earth is not a stable background object in the story of human civilization. It's a character. An active, occasionally temperamental character with about 3 million volcanic vents and no obligation to warn you in advance. And on most days, it's choosing not to use them.